What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we look at applications of exponential and logarithmic functions. Today we are going to talk about an equation that actually doesn't have a lot to do with exponential or logarithmic equations, but coincides with some of the information that we are going to progress into, and so we are going to cover the topic of simple interest. Simple interest is essentially one of the types of interest that can occur in the financial world, and it's designated by a single one-time interest payment. So we have this equation here. Let's jot down that this is a one-time interest payment or accrual. And it follows this equation that we have listed here. I sub t, the interest with respect to time, so let's just let this be interest, is equal to P, the principal. Principal is another word for initial amount or initial quantity, something that we saw previous with our previous equation for exponential percentage growth. R is still going to stand for the rate, and T is still going to stand for time. So interest is equal to the principal times the rate times the time. So we can see here there's not really a lot of work with exponents, but because it goes along with some of the other financial equations that we're going to look at, we're going to touch base on simple interest here very quick. So the mathematics, the computation of these types of problems are not going to be too difficult for us, just kind of the understanding of the formula and the use of the formula. So let's go ahead and take a look at an example. An example number, problem number 8 here, it says, many finance companies offer what have become known as payday loans. A small loan, $50 in this case, to help people get by until payday, usually no longer than 2 weeks. If the cost of this service is $12.50, determine the annual rate of interest charged by these companies. So the cost of the service is the interest, because you're going to have this small loan, which is going to be the amount that they give to you and the amount that they return, that you return back. And then on top of that, you're going to have this $12.50, which can be known as a one-time payment, which would be counted as your interest. So that's going to go in for I of t on this equation. The principal is the initial amount, the amount of the loan or the amount of the account balance, which would be $50. Now, in some cases, we are given a payback amount, an initial amount, and a payback amount, and we have to find the interest. But in this case, they are giving us just the extra cost on top of the loan, would be the interest. So we have interest, we have principal. What we don't have is rate. So we want to find the rate. Now, time is where this kind of can get a little bit difficult. What we realize is that we want to find out that, or we know that this $50 loan is for 2 weeks, a 2-week time domain. But we want to find annual interest. Annual interest or rate of interest, the annual rate is with respect to a year. So the loan lasts 2 out of the 52 weeks in a year. So our time value is actually 2 over 52 here. So that can vary depending on what your rate percentage is at. We did talk about some mindful manipulation of percentages prior to this section. If you haven't watched that video, make sure you do so. And here we see some of the similar concepts where we're looking at a rate as an annual number, but our loan is in weeks. And so we can put that into a ratio here to represent the time. Now I can solve this equation for R. And so initially I would probably want to divide both sides by 50. So 12.5 divided by 50 I can do here in the calculator. So that would give me 0.25 is equal to 2 over 52. Let's go ahead and simplify this as 1 over 26 times R. And so then I would multiply both sides by 26. And so R equals 6.5. This is the rate. This is not the percentage. So if we convert this into a percentage, this is a 650% annual rate of interest. So over the course of the year, over the course of the year, if someone were to take out a simple interest loan of this type for an entire year, that interest would amount to 650% of the loan. So we can see here that though these payday loans may be necessary in some instances, if there are other ways to go about getting this loan at lower rates, it's probably a better option because this is an extremely high rate. So this is just an example of simple interest, not an exponential logarithmic equation, but something that's going to coincide with the following lessons. As always, thank you guys for tuning in, and I'll see you.